Okay, before we start this lesson, I want you guys to go ahead and jot down these review notes. So pause the video, get all of this information written down. This is all stuff that you learned in book 1 during 7th grade. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. The slope formula is rise over run. So you're going to do y2 minus y1 over x2 minus x1. The midpoint formula, we just average the x's and average the y's. And then down here I put the distance formula and the Pythagorean theorem together because both of those formulas are used to find the length of a line. Now, it's pretty obvious that the Pythagorean theorem is a lot simpler looking than the distance formula. Now, they are the same formula because if you take the square root of both sides of the Pythagorean theorem, you get c equals the square root of a squared plus b squared. And this is just your a, and this is your b. So it's the square root of a squared plus b squared. When we're using graphs like the triangle that's next to this, using the Pythagorean theorem is probably going to be the easiest thing for you to use. But you're welcome to use the distance formula anytime you have two ordered pairs. Okay, so pause the video, jot all those notes down. Okay, now we're going to come back to our triangle, and we're going to start by finding the length of all of the sides of this triangle. Now, the Pythagorean theorem only works for right triangles. So we're going to work these together in your notes. Since triangle ABC is not a right triangle, in order to find the length of AB, we're going to sketch in a right triangle. So we're going to start at point A, and we're going to go up 3 and over 7, and that's going to create a right triangle for us. Here's our right angle. So we have a leg of length 3 and a leg of length 7, and now we can find the length of AB. So we're going to use a squared plus b squared equals c squared, and c is going to give us our hypotenuse. So a is 3, b is 7, and then we're looking for c. C is AB, so if you wanted to write AB squared instead of c squared so that you knew what you were finding, you could do it that way. Okay, so 3 squared is 9, 7 squared is 49. We get 58 is AB squared. Remember, AB is just saying the length of segment AB. You take the square root of both sides. Here, I can switch this up some. Take the square root of both sides, so we get the square root of 58 is the length of AB. So we have the first side of our triangle, and now we're going to find BC, and we're going to find AC using the same technique, continuing to use the Pythagorean theorem. Yes? Since it was equal to AB squared, I had to take the square root of both sides, so I came in here and did the square root of both of them. Since we're talking about the length of a side, we don't need the plus or minus when we take the square root. We know it has to be a positive length. Okay, let's find BC. The length of BC. We're going to make a right triangle. And that triangle can be either on the inside. You can go straight down and over. There's always two ways to make that right triangle, and it's never going to matter one way or the other. Yes. Thank you. We only use the line if we're talking about the segment as a shape. When we're talking about the segment's length, we don't put the bar over the top. Okay, so the length of BC, the little leg is 2, and then the long leg here is 7. So those two lines were almost perpendicular. angle B is really close to being a right angle, but it's not. So we're going to do a squared plus b squared equals BC. Oops. BC squared, and we're going to plug in what we know. 2 squared, 7 squared, 4 plus 49 is going to give us 53. Take the square root of both sides. So the square root of 53 is the length of BC. And then we have one more. I'm going to let you all come up with the length of AC on your own. Practice the same steps. Okay, we have found the length of all 3 sides of the triangle. And now we're going to go ahead and classify the triangle both by its angles and by its sides. So when we're classifying it by its sides, we want to know how many sides of the triangle are the same. Well, none of these numbers were the same. So since all 3 sides of the triangle are different, it's going to be a scalene triangle. So that's the first thing we know. Then we want to look at the angles. Every triangle has to have 2 acute angles. So the question is, what's the third angle? So we can see A and C are both acute angles. The question is about B, and we started talking about that earlier. The slope of AB is positive 3/7. So if the perpendicular slope has to be the opposite reciprocal of 3/7, then the perpendicular line would be negative 7/3. So we would go down 7 and over 3. Well, if it was a right angle, it's getting kind of hard to see with all that. The line would need to be all the way out there. So this angle in here must be an acute angle. So since all 3 angles are acute, this is going to be a scalene triangle and an acute triangle. So that's just a quick kind of review of all of those things that you learned last year. And now we're going to move on to triangle mid-segments. Okay, so this is going to be in chapter 6. In your book. I'm going to give you a minute to write all of that down, and then we'll fill in the blanks. Okay, in 6.5, we start talking about triangle mid-segments. And a mid-segment connects the midpoints of 2 sides of the triangle. So we're going to choose 2 sides. We're going to choose AB and BC, and we're going to find the midpoints of each of those, and then we're going to connect them. You can kind of gauge on the picture about where they're going to be, but I want you to practice using that midpoint formula where we average the x's and average the y's. So to find the midpoint of AB, we're going to use point A and point B. So we're going to average negative 4 and 2. Negative 4 plus 2 divided by 2. And then we're going to average 1 and 3. 1 plus 3 divided by 2. And then when we simplify, that gives us our midpoint of negative 1, positive 2. And when we create a new point, we want to give it a name. So for this one, we're going to use M for midpoint. Now the next one can't also be M, but that's okay. And once we have that midpoint, we're going to go ahead and plot it on the grid. So we're going to go over negative 1, up positive 2, and there's M for our midpoint of AB, right there in the middle. Negative 1, positive 2. The next thing we're going to find is the midpoint of BC. So BC is the point, we have 2, 3, and 6, negative 6. I'm sorry, 6, negative 3. We'll do our averaging, 2 plus 6, x plus x, divided by 2. And then y plus y, divided by 2. So 3 plus negative 3. divided by 2, which gives us 4, 0. And we need another name, so we're going to name this one n. So at 4, 0, so over 4 and up 0, that's right here, is point n. So that we said the mid-segment connects those midpoints. So the mid-segment is going to be, for us, mn. So mn is a mid-segment. Triangles actually have 3 different mid-segments. So depending on the problem, sometimes they want you to find all 3, and sometimes they want you to find just one of them. To find the other 2 mid-segments, we really only need one more point. We would just need the midpoint of AC, and then if we connected it to either of those other midpoints, it would give us, here would be another mid-segment, and here would be the 3rd mid-segment. But for this one, we don't need this. I'm going to erase it so we don't have that extra stuff. Yes?
So basically like a mini triangle.
Yeah, you end up with a tiny triangle inside the original triangle. Yes.
Wait, so when you see like those photos, you have 2 double triangles?
It depends, but sometimes it is, yes. Okay, so I want to compare our mid-segment MN with that other side, that 3rd side, AC. When you look at them, do you notice anything about them?
They're parallel.
They look parallel. So what we're going to do is we're going to find the slope of those 2 lines to test and see if they're parallel. We're just going to use rise over run since we have the graph. So for MN, it would be going down 2 and over 5, so negative 2 over 5. And then the slope of AC would be down 4 and over 10. So that would be a slope of negative 4/10. Yeah, that simplifies to negative 2/5. That M has way too many humps, but so they're the same. And when the slopes are the same, we know that that means the lines are parallel. So down underneath this, I want you to write MN is parallel
Do you
to.
find the slope by getting
It's,
drawing that little dotted line?
yes,
Okay.
I just did this is the rise, and this is the run.
Okay, yeah.
It's a lot like the Pythagorean, what we do for the Pythagorean theorem. Yes. The same, I just didn't draw in the triangle. It was getting a little bit busy. Yes, the double slanted lines means parallel. I did put the bars over MN and AC because I was talking about the segments, not their lengths. The segments are parallel to each other, so that's why we use that. Okay, the last thing we're going to do is we're going to find the length of both of them, and you can use the Pythagorean theorem or you can use the distance formula, either one.
Can I make a prediction?
Yes.
MN is going to be half the time AC.
What do you guys think?
Do you agree? I think that means all in favor.
Okay.
I'm in favor.
So the question is the length of our mid-segment going to be half the length of the longer segment?
It looks.
Yeah. It certainly looks like it could be. So we're going to test it by using our formulas. So for MN, that was the little one, we can use the triangle we made for finding slope. Right? We can use this little triangle. So it has a leg of 2 and a leg of 5. So 2 squared plus 5 squared equals c squared. We square both of them. Be sure you square them and add before you try taking the square root. So this is MN. The length of MN is the square root of 29. And I would just leave it the square root of 29. I would not make it into a decimal. Now, to find the length of AC, we go back to the other right triangle that we had. This leg was 4, and the leg across here was 10. We could simplify that when we were talking about slope. When we're looking for the length of a triangle, we don't change those lengths. So we're going to go in and use our Pythagorean theorem again. Plug in your leg lengths, 4 squared and 10 squared. We're going to solve the formula. So C is the square root of 116. So is that twice as long as the square root of 29? Well, I don't know. But we can see, does this simplify?
Yes.
So is 116 divisible by a perfect square? Is it divisible by 4?
Yes.
Yes, because 16 is divisible by 4. So 116 is actually 4 times 29. And the square root of 4 is 2. So that simplifies to 2 times the square root of 29. So it is. It is. So there's 2 things we just found out. When we make that mid-segment, one thing is it's parallel to the other one, and it's half as long as that other one. So I want you to jot this down. This is the theorem that we were looking for. The mid-segment theorem says the mid-segment of a triangle, so that's that MN, is parallel to the third side, side AC, and it's half of its length. I'm not sure. Let's see if this works. No, I did that right. Okay. I'll let you write that down. Okay, I just put that pink line on top of MN. And look when we, oops, let me grab it, the computer. No. Look here, when I put this one right here, do you see how it is? It's about twice, about half as much, the pink one is. Okay. So the last piece that we're going to cover today is the Triangle Inequality Theorem. And the Triangle Inequality Theorem is what we use to decide if we have 3 lengths, do those 3 lengths form a triangle? Is it possible to form a triangle with these specific lengths? And so I can draw you an image. Let's see. If we have a length, if we have one that's this long, and we have one that is this long, and we have one that is this long. Can those 3 pieces be put together to form a triangle? No. So not everything can make a triangle. Not all 3 sets of numbers can make a triangle. Okay. So the way we test to see if it forms a triangle is we look to see if 2 of the sides together are longer than the third side. Okay. And the reason we do that, let's see if I can do it with these. If I take, it's not gonna let me touch it. I'm gonna do it from over here. If I take this and I put it down here, they don't match up very well, so we'll just pretend. I take this one and I put it over here. We said they're not gonna make a triangle. If I take this one and I extend it, are they going to make a triangle now? Probably not yet, but maybe if I get all the way over here, then could they form a triangle? Yeah, probably, so I could swing that one around. Okay, so what we do is we add two sides together, and those two sides together have to be longer than the other side. Okay, so side A, when added to side B, that number has to be longer than side C. A plus C together has to be longer than side B, and B plus C together have to be longer than side A. So we write it like this. Oops. Side A plus side B has to be greater than side C. B plus C has to be greater than A. And A plus C has to be greater than B. So if they tell you that this is 8, and this is 6, and this is 15, is it going to work?
Yeah.
Because what's A plus B? 23. Is that bigger than 6?
Yes.
Yes. And 15 plus 6 is 21, which is bigger than 8. 8 plus 6 is 14, which is not bigger than 15. So these three sides could not make a triangle. But if we made this side 10, now it would make a triangle. Those things would make a triangle. The other thing we said at the beginning of class was, what I want you to remember is that the longest side is always opposite the biggest angle. So if A is the biggest angle, then this side opposite A has to be the longest side. So looking at these numbers that I gave you, the 6 and the 10 and the 15, which one of those angles would be the biggest angle? A. Which one would be the middle angle? B. And the smallest angle would be C. So they'll give you angles and ask for the sides in order, like greatest to largest, greatest to smallest, or smallest to biggest. Or they'll give you the sides and ask for you to do the same thing with the angles. And you just do that based on what they're giving you. Some of them you have to actually solve. What do all of the angles of a triangle have to add up to? 180 degrees. The sides of a triangle can add up to any positive number, but the angles have to add to 180. And that's the end of what's going to be on today's worksheet.